Hey everyone, in this video I want to talk about ephemeral disks. Now ordinarily when I provision and create a virtual machine, that virtual machine when it started runs on a specific host. Yes, it's the cloud, but that VM is not running on some magical compute capability. It gets placed and provisioned onto a specific host. So I can think that, okay, we have lots of these hosts split into clusters. And when that VM is either created or it started after being stopped and deallocated, well, a certain host is picked. So that VM springs into life and can consume the resources of that host, the CPU, the memory, the network throughput, etc. If I think about the operating system disk, we have two options for that. Now, ordinarily, we care about the operating system. We maybe call it a pet. There's unique configuration of the operating system. I don't want to lose it if something happened to this node, if I stopped it, if I hibernated it, whatever it would be. And so the operating system disk, we create it as a managed disk. Now that managed disk behind the scenes is on a abstracted storage account. But I get this managed disk created for me. I can have different levels of resilience. It could be a locally resilient disk where there's 3 copies within a certain storage cluster. It could be zone redundant, where those 3 copies are spread over the 3 AZs in the region, but it's highly durable. And so this managed disk gets connected to the virtual machine for the operating system. Now I can also add additional disks for data purposes, and I'd always want those to be durable in most scenarios. Now, if I think of this managed disk, it's highly durable, but it also means, well, there's a certain amount of cost associated with it because it's consuming a certain amount of storage. It's a certain SKU, standard hard disk drive, standard SSD, premium SSD, ultra disk. The cost will increase, but so too will the performance, and I'll reduce the latency. But there is also the consideration here of latency. It is not local to the host. So there's a certain amount of distance traveling between the host and the disk. And again, depending on that particular SKU I pick, I'm going to get a certain latency. And there's 2 dimensions to that latency. There's the latency, yes, of the ongoing interactions with the disk, but then there's also a latency when I first create that virtual machine and the time required to create that managed disk to then do the actions on it. So it's going to slow certain things down. But the benefit here is I can hibernate this virtual machine. I can stop and deallocate it so it's no longer consuming any compute. This is a separate resource. I'm still going to maintain the state of that operating system. But there's times I don't care about the state of the operating system. It's not a pet. We kind of use the term cattle, where there's nothing particularly unique about that particular operating system. And so why use a managed disk that costs me money that potentially has lower performance than what's locally available in the host? Because for many of the VM SKUs we have, also within this host, is solid state storage, has these SSDs. And it uses it in potentially one of 2 ways, and it could be both of them. So for some VM SKUs, typically it's the little D variant. It means it has a temporary drive. So a portion of this is broken out, and it's used as a temp drive that then gets connected to the virtual machine. Now, it is a temporary drive that is non-durable. If I deallocate the VM, I'll lose the content of that. But also, if the VM is enabled for premium type storage, it will use a portion of it for caching purposes. So this SSD is local to the node, which means it's super low latency, and it's an SSD. Very high IOPS, very high throughput. But the key thing here is it is not durable because it's local to the node. And so if I was to stop and deallocate the VM, so it's not allocating any resources on the node, well, its temp area, its cache area goes away. So in reality, if I was trying to use this for other things that I care about, hey, I could never stop, I could never deallocate the VM. If the node crashed, I lose that temp content, I lose that cache content. But ordinarily, hey, it's temp, don't care. Maybe I'm using it for temp DB, for a database to get that very low latency, high performance. It's using it for caching, but it's just caching. The actual data is still on whatever managed disk that might be. But if there's times where I don't care about the state of the operating system, well, that's when we have the option to use one of these. And in that case, we can actually store that OS disk on one of these. So over here, we basically create our OS disk on top of either the temp or on the cache storage. And then that is our virtual machine's operating system disk. But this would be ephemeral disk because it's not durable in the sense of a managed disk. It's just running on this local SSD. Yep, great performance, low latency. But if I stop and deallocate the virtual machine, this content disappears as well. So that's really the important point. Now, how do I know if my virtual machine supports this or not? Well, it will tell you. So if I go and look at the virtual machine SKUs, so notice here, for example, I'm looking at, it's got this little D, that means it has temporary storage. And then one of them has the little S, which means it supports the premium storage. So if I was to just look at the DDV5, it's telling me here, Ephemeral OS disk is supported, and it's telling me the size of my temporary disk. For the DDS, well, that's also going to support the Ephemeral OS disk. Now, on the older SKUs, I think it was like the version 2, version 3, if we looked at one of those, it would actually tell you the size of the cache. So if I go and look at an S variant, it would tell you in brackets cache size in gigabytes. So hey, there's 50 gigabytes for caching, 100 gigabytes for caching, 200. It does not do that beyond the V3. So the V4s, the V5s, it does not show you that. You can still peek. So if I use PowerShell, one of the things I'm actually looking at here, if I use the get AZ compute resource SKU, I can go and look at a couple of properties. And specifically, it will tell me if it supports that ephemeral disk on the resource disk, which is the temp drive or the cache disk. It will tell me the amount of cache disk bytes, and it will tell me the max resource volume megabytes, i.e. that temporary disk size. And so I've run this already, and if I just dump this out, it shows me for all the different SKUs, hey, where does it support running that ephemeral disk? So you notice some of them is only the temp disk, the resource disk. Some of them, it could be the temp disk or the cache disk. Now, the reason it doesn't show it for the V4s and V5s in that table is it's not always accurate. There are other things going on. It's not always dedicated. So although I'm showing it in this right-hand column, it's not always something you can trust. And really, there might be a little bit of experimentation. But the reality of the situation is, for most of the SKUs, when we actually go and look at it today, it wants to use the temp disk space anyway. So primarily, it's going to use that temporary drive. That's what it's going to lean towards. Now, there is some legacy code in there. If a VM SKU supports both, it actually checks, well, is there cache space first? Hey, I'll try and use that and then use temp. But if you look at the newer SKUs, the direction is the temp drive is always supported there. So for the V4, the V5, you'll only see it support ephemeral OS disk if it has a temporary disk. Doesn't matter if it has a cache space, it won't say supports ephemeral disk if it doesn't have a temporary drive. Now, in terms of how big can that OS disk be, well, these have specific sizes. And so the OS disk, basically the image I'm using for the OS disk, has to be smaller than the largest of the temp or the cache, but then the maximum it can possibly be is basically 2 terabytes. So I can't support an OS disk bigger than 2 terabytes when I'm using an ephemeral OS disk. So again, it's whichever is smaller, 2 terabytes or which of these are available. Because again, it's going to store that disk on this temp or cache area. Now, if I use this, realize primarily it's going to try and use the temp disk. If my image was 70 gigabytes and my temp drive is 100 gigabytes, well, it's going to consume 70 gigabytes of the temp drive. So I only have a 30 gigabyte temp drive now. If my OS disk is now the entire size of the temp drive, I won't get a temp drive at all. So it is consuming these spaces to provision that disk onto. But from a benefits perspective, realize, well, this is now super fast to provision, and those interactions, super low latency, because it's normally talking definitely sub-millisecond, microseconds, because it's just a local SSD, and the IOPS and the throughput will be huge. So scenarios, hey, I'm talking about a virtual machine, but realize all the things that are built on top of virtual machines. So if I think of anything that uses a virtual machine scale set, by definition, most of the time, a VM scale set is automatically scaling out and then it's creating and deleting the instances as my load or whatever I'm looking at to drive that scale action, which means I can't care about the state of the operating system because I'm willing to just create and delete them. And so that would be, if I can, a great use case to use ephemeral disk for the operating system to save the money and actually get a higher performance. If you look at things like Azure Kubernetes Service, well, that's built on virtual machine scale sets. And by default, it will use ephemeral disk if the VM SKU supports it. App services, they build on VMSS. A lot of other services build on VMSS. And so this is a hugely useful capability that, if I don't care about the OS state, doesn't really have a downside. Now, the creation is super simple. If I was to just go and look for a second, if I'm in the portal, now I've picked a VM SKU that has enough cache and temp disk. If I was on the previous screen, so what I picked is this D8 DSV4. And then when I go to disks, if I go to the advanced area, it's giving me a choice. Do I want to use Ephemeral OS Disk? And if I do I want it to use the OS cache or do I want to use the temp disk space? So I get to pick. And the same thing would apply through CLI, through REST, through ARM, etc. And the documentation goes through each of them. So hey, if I want to be able to use it, it tells you, yep, there's the placement option for where to create this from here. I can do it through the CLI. Again, Ephemeral OS Disk true. Hey, use the temp disk, the resource disk, using REST, etc., etc., etc. So I can go and create these really through any of the different mechanisms. So what is the downside of using this? Well, obviously, it is on the local node. So what I don't have resilience from now is, for example, if there is a failure on the node, if it crashes or something, I've lost the state of that operating system. The whole point here is I use this when there is nothing unique. There's nothing I care about on the OS disk. Remember, I can still have data disks that are managed disks that are still durable. It's just there's nothing special about the OS state. So there's a lack of resilience to failures. I can't stop deallocate the virtual machine because, well, a virtual machine is, yes, the compute resource. It happens to be running at that moment in time, but it's the operating system. Well, the operating system disk will disappear as soon as I stop deallocate. So what I can't do is I can't stop deallocate anymore. I have to just delete it. So I delete, and then I would create it again when I needed that unit of work that it can do, which is what VMSS does. Typically, it's default for its scaling. It creates, deletes. So I can't stop deallocate. I can't hibernate. Because what does Hibernate do? Hibernate saves the state of the memory and the CPU into the OS. Well, it's gone. There is none of that anymore, so I can't hibernate. If I stop paying for the compute element, it's all going to disappear. I can't use those functionalities that need that. I'm essentially a stateless system, but that's typically what we want in these scenarios. There's a whole list of other things that aren't supported. If you look at the documentation, we can't capture VM images, we can't do disk snapshots, can't do Azure Disk Encryption, Azure Backup, ASR, or OS Disk Swap. You can use trusted launch still, so documentation does go through that, but just be aware of those scenarios. But it really does boil down to the fact that I will use the Ephemeral OS disk if my VM SKU supports it, and where I'm in a scenario where there is nothing unique that I care about in that OS disk, typically because it's part of some automatic scaling function, virtual machine scale set, anything built on top of a virtual machine scale set, or it could just be other workloads I'm manually creating where, hey, I can just reimage it very, very simply. And I would like the idea of not paying for the managed disk. And I like the idea of getting that very low latency, both in terms of performance and in terms of the provisioning of that scenario. And then I get those very high IOPS, very high throughput. There are scenarios where maybe I'm rapidly deleting and creating virtual machines. This is fantastic for that because, again, I'm not getting stuck and hung up on the creation and deletion of that managed disk resource. So that was it. I just wanted to quickly go through what the Ephemeral OS disk was and why you might want to use it. Until next video, take care.